This is SARS-CoV-2, the coronavirus responsible for COVID-19. This complex and deadly virus has been the center of attention worldwide. The most critical aspect of stopping its spread? COVID-19 testing.
Imagine a long set of dominoes, one after the other. If one line of dominoes splits into multiple paths, removing even a single domino within the starting line will prevent the falling of those subsequent paths.
That is a part of why testing is so important. Similarly to the COVID-19 pandemic, by testing many people, we can determine who are infected and isolate them, effectively removing their domino. By testing people for coronavirus, we can isolate and treat those who are infected and mitigate spread of the virus. But what are these tests and how exactly do they work? One of the most common testing methods is nucleic acid testing. The most commonly used test in all clinical laboratories is a type of nucleic acid testing called an RT-PCR assay. This stands for reverse transcriptase polymerase chain reaction. But what does all this mean?
The aim of an RT-PCR test is to amplify the viral genetic code. Viral RNA is taken from your cells via a mucus swab. The enzyme reverse transcriptase reverse transcribes the RNA into complementary DNA. That DNA is then copied over and over in a polymerase chain reaction. Each cycle of PCR has 3 steps: denaturation, annealing, and elongation. In denaturation, the DNA is heated to a high temperature which breaks the hydrogen bonds connecting the strands. During annealing, the DNA is cooled and short DNA sequences called primers bind to viral target sequences in the separated DNA, preventing parent strands to pair up again. Lastly, in elongation, heat-tolerant DNA polymerase binds to the primer and copies the viral strand.
With every cycle, you can exponentially increase the amount of viral DNA from just one sample. When there is a large enough quantity of the target sections of viral DNA, scientists can accurately confirm that the virus is present. However, recently, new kinds of tests that may be the future of COVID-19 testing are beginning to appear. One of these new tests uses isothermal amplification, which also aims to exponentially amplify the amount of viral RNA. Isothermal means at a constant temperature, meaning it can detect the virus without having to go through the time-consuming heating and cooling cycles.
The secret to this experimental test is something called a nicking enzyme amplification reaction, or N.E.A.R. This test makes more copies with a template similar to a genetic copier printer. Added enzymes find the copy pieces of viral code and nick or cut the replicated viral code out of that template, just like a paper cutter on a printer. These genetic copy printers print from both ends, so it spews out 2 new viral sequences with every print. Each viral sequence copy also gets a fluorescent beacon using an intercalating dye. Imagine it's leaving the printer with a big streak of glowing highlighter on it.
This amazing rapid copy print of viral sequences can determine a positive ID of COVID-19 in just a few minutes. Testing for COVID-19 may be complex, but it's essential in stopping the spread of the virus. Remember, these tests may work microscopically, but their impact leaves a mind-blowing influence on the lives of